Better. So my name is Mano Marks. I'm a developer programs engineer at Google. My job is to help people with KML and the new Earth API. So let me just give you a quick overview of what I would like to talk about, and then I want to ask you what you'd like to talk about. So, so get ready for that. KML is an open standard. It was originally developed for Google Earth. So it's the keyhole markup language. The company that made Google Earth was called Keyhole before it was bought by Google. We released it, we finalized the release of it this year to the Open Geospatial Consortium, so it's now an open standard that many people are writing their applications to. It's a standard developed for geographic data presentation, and it works in what we call an Earth browser. So Google Earth is an Earth browser, Google Maps, Microsoft Visual Earth. There's a number of different products out there that now support KML. So what I'd like to do is talk about some of the advanced features of KML. So I want to talk about network links, regions, view-based network links, and time animation. I also want to give an overview of the Google Maps API, mostly probably just showing some examples of it working and a little bit of code, how you can do sort of some quick start on it. But what I would like to do right now is ask, first of all, I'd like to ask how many of you have actually used KML before? Okay, good, a fair number of you. How many of you have developed using the Google Maps API? Okay, fewer, okay, good. So then what I'd like to do is ask, do we have like microphones for questions? If anybody has any questions, things that they'd really like to cover before I actually get started, raise your hand and we'll send a microphone around. And I'll get my translation. So anything that you would like to know about Google Earth, the Google Earth API, or KML, want to make sure that I cover? Just raise your hand. Wow, nobody? Okay. Well, then I'll go into my presentation. You'll see there's some slides up here. This is my first slide. This is my last slide. I don't use slides very much, but they wanted me to make sure that I put that up there. So that'll go into some video somewhere, which will be on the web. Currently, the KML documentation is just about ready for. It's just about translated into Japanese. I think we're going to release it sometime very soon. So you can go to code.google.com to get more information about that. So keep checking back because it'll be there. I'll put that slide up again at the end if you really want to see it. Okay. So the first thing that I want to do is talk about using Google Earth and Google Maps to create KML. I talk about this at every talk that I give because it's something that not a lot of people actually realize that you can do. So I'm going to do a very quick overview of it, show how to create a place mark, a point, and a line string, and use that as to talk a little bit about KML, and then show you, you can use it to create other things in KML as well. Okay, so this is Google Earth. I think most people have probably seen it. At least you probably saw the keynote this morning where we showed the Earth API. There are tools built in here for doing your own annotation. So you'll see up here at the top, there's add place mark, add polygon, add path, add image overlay, and also if you go to the add menu. And of course in Japanese this is going to look different, but I don't actually speak Japanese, so I couldn't navigate the menus. But there's a few additional things like adding a model, a photo, and a network link. So I'm going to show you how to make a place mark. It's actually very easy. I'm going to go to Yokohama, Japan. And I have my fly to speed set kind of slowly, so that's why it's taking a little while to get there. And I'm going to clear that result, and I'm just going to take this the place mark, which it then puts in the middle there. I can still zoom in and pan around if I want. As long as this properties window is open, I can move this around. So say I want to plop this down here. Seems like a good place. You'll see it finds the latitude and longitude. I'm going to change the icon. I can change the style here. So I'm just going to change the style of the label to be green. And you'll see it did that there. And I'm going to just call this demo place mark. And I'm going to give it a little bit of altitude and extend it to the ground and click OK. So you'll see now I have a demo place mark. I didn't put a description in it, so when I click on this, there's no description. Well, that's great. It's now sitting in your My Places on your computer. But if you want to share that with somebody or you want to edit it in a text editor, easy thing to do. In Windows, you right-click. I think it's a command-click on Macintosh. You click Copy, open up a text editor. On Windows, I like Notepad++. Just create a new text document and paste it in. So a lot of people don't realize you can do this. You can copy and paste. You can actually paste back into Google Earth as well. So you can use this as a quick and dirty way to create KML. So there's a lot in here about style, which I don't have a lot of time to go over at the moment. But it's not actually that complicated. There's just Google Earth creates a lot of default style information for you that handle things like when I hover over this, you'll see it gets a little bit bigger. So that's what all that style information is. The sort of the meat, the data piece of it, if you will, is this place mark element. So here's our first little difference between Google Earth and KML. In Google Earth, it says add a place mark, and by that it means a point. You want a point on there. But in KML, any geometry, your point, your polygon, or a line string is contained within a place mark element. So you'll see some of the basic things that it has. It has a name element, which we gave it the demo place mark. A look at, when you use Google Earth, it creates a default look at, and the look at is if I were to double click on the place mark, the position that it would go to, you see it causes a movement. So it'll take us to a particular place where that's the look at of this. Thank you. Of this place mark. So when you double click on it, it goes to a particular location. It creates a style URL. So the style URL just points to one of these styles up in here. And then it creates a point. Now this is your geometry. So in this case, a point means a point on the map. And the point has an extrude value of 1. Extrude means that it's, you'll see how it's above the ground, but there's a line pointing to the ground. That's extrude. And it has an altitude mode of relative to ground. That means that the altitude it's at is relative to whatever the terrain is. The 3 modes are absolute, relative to ground, and clamp to ground. Relative to ground just says, add the altitude to whatever the terrain level is to get the actual altitude. Absolute means take this as the absolute altitude above sea level no matter what terrain is. And then clamp to ground means clamp it to the ground no matter what the altitude is. You'll see there's a coordinates element in there, and there's the longitude, latitude, and altitude. Those are the 3 values in that order. And for a point, you only have 1 set of coordinates. So that's how you create a basic place mark. I'm going to quickly go over how you create a basic line string, which is very similar. You create the line string, you lay it out, you do the different points. You can do a style for it, create a view, and do altitude and extrude if you want. Extruding for a line string ends up creating sort of a wall effect. And then again, I can copy it from the My Places panel. I can go to create a new text document, and you'll see again we have all the style information. Again, we have a place mark. So you see there's a place mark element, but the geometry contained within it is a line string, which is what creates the line. And so the only difference really with that is you'll see that this is one coordinate. That's a coordinate of the first point in the line. This is the second coordinate, the third, fourth, and fifth. So those are just the ones I created in that order. And so you'll see there's a longitude, latitude, altitude, and then there's a space or a line break, and then the next set of coordinates. Okay. So that's the basic way to create it in Google Earth. And let me pull up Google Maps and show you there how you do it. So you go to maps.google.com, click on My Maps, click on Create New Map, and here I'm going to log in. Please don't memorize my email, my personal email address. And you'll see it's created a map, which I'm going to call demo map. And you can share that with other people if you want. You can use this as a way to collaborate with people. I'm not going to get too much into detail here, but again, you have these simple tools for adding information about the place marks. I'm going to call this demo place mark 2 and give it a description. This is where I want to live. Probably not really, but I'm just wanting to give it something. And then you click on View in Google Earth. First you save it, then you click on View in Google Earth, save it to disk, and I'm going to now open that file. And next time I do this, I'll set my fly to speed faster. But then you'll see there's the demo place mark 2 that I created. So this is interesting. So let's just take a look at that KML file there for a minute. You'll see this isn't actually a point there. This is actually a network link file. So this is one of the advanced features of KML, creating a network link that points to a file that resides somewhere else. So in this case, it's actually pointing to a server that will produce a file in response to the request. So you'll see here we have the document element, which is just a container, the network link element, which says this is a network link. It's got a link element inside of it, and inside of that, it's got an href element, which points you to the location of the file. And so it's just maps.google.com, a whole bunch of parameters, including an ID, and then output equals KML. But if you wanted the KML of that actual place mark, you could go to it, right-click on it, copy, paste, and there is your actual KML file. Okay, if I wanted to do something more, I could do something like this, where I did Mano's test file, I'm going to give this a different name. My other house. And I'm going to copy this and go into Google Earth and get rid of that one and paste it. And you see I can paste it directly into Google Earth as KML. So, all right. So that's very basically how you use Google Earth and Google Maps to create your own KML files. All right. The next thing I'd like to talk about is time and time animation. So this is I'm going to clear out the contents of that. This is a file I have. I'm going to go to Tokyo, Japan. It's population of Tokyo, Japan over time. So basically what we're going to look at is polygons in Tokyo that represent the relative populations of different districts. Oh, and I should probably, in the meantime, get rid of this path. Okay. So you see here we have a bunch of polygons. At this point, they're clear gray plain polygons, and they're different heights. And the different heights represent the different populations of the different districts of Tokyo in 1955. You'll see up here at the top we've got a time slider which we can play, and as we start to play it, and as the time reaches 1960, you'll see that the polygons actually change. So you'll see that some of the polygons are red, and that means that they've designated red as a raising population, and blue as falling population during that time period. And you can see how different districts of Japan, of Tokyo rather, change their populations based on that. So the question is how do we actually accomplish this? I'm going to just let this run for a little bit longer so you can see they actually project the populations into the future. So you'll see in a minute it'll hit 2010 and keep going. And obviously we don't know what the exact populations are, but this is the population projections. Okay, so how do they do this? And by the way, I didn't create this KML file. This is something that was created out in the community, so I can't verify the actual numbers that are represented here. So anytime you find KML, and you want to know how they did something in particular, you can, of course, use the same technique of right-click, copy, and select into here. So the key thing in here is, you'll see this is a rather large thing. What I did was I took this folder, which represents a particular 5-year time block, and I copied it and I pasted it into my text editor. And at the top, you'll see, of course, there's a bunch of styles again. I don't mean to dismiss styles. They're complex topics, and the documentation covers it much better than I do. So I'm scrolling down to try and get past that. Okay, so then the first thing we see here is a screen overlay. And the screen overlay basically points to an image. So a screen overlay is this. So for instance, here you have Tokyo population. You see how when I move around, or the year, for instance, when I move around, those numbers don't change. Or the positions of those don't change, whereas everything else does. So the screen overlay just overlays it on top of the screen of the 3D browser. Let the translation catch up. Okay, so then we have here a folder. Actually, I'm going to skip to the meaty part. I'm going to do a little search. There's a time span element. So there's two types in KML. So you see this is actually at the container level. So this is up at the document. That means that anything in this document has this time span. So the time span has a beginning and an ending time. So the begin time is 1960, and what that means is January 1st, 1960 at 12:01 a.m. But you can just put in 1960 and know that it means the very beginning of the first day of that year. At the end, we need to specify all the way through that day. So it was 1964, 12/31, so that's December 31st, 1964. So time span is a time element that says this will exist for this span of time on the time continuum. So when that time is active in the time slider, you will display this, and if it's not active, then you won't. There's another element called a timestamp, which just has a single child element, which is called when, and it takes the same kind of time, and that means just for a single instance, when that shows up on the time slider, you'll display that, and then it will go away. Okay. I want to ask right now, I love more interaction, so I'm going to ask right now if there's any questions. So if anybody has any questions, can you, okay. Can you bring the microphone over to them? Tim?
Thank you.
Yes.
Can you handle BC years?
Yes. This is a common question, and people aren't sure how you do it. You just put in a negative sign in front of the year, and it'll work.
Okay, thanks.
Sure. Any other questions? Here. Oh, I suppose
Can I handle events? Click on 3D object on Google Earth.
Can you have the
Events.
events?
Yes.
So in Google Earth, in just the plain Google Earth, not the Google Earth API, the only effect that time has is whether it shows up or not. So it's not about whether you're clicking on it. Google Earth itself is not scriptable, so you can't use anything. You can't use JavaScript, for instance. However, you could do that in the Earth API.
Thank you.
Okay. Any other questions? Time for about one more. Yes, back there.
KML でコードがマイナスのデータを、見せる表現して、それをコード的に見せるということは可能でしょうか？
A negative altitude? No. At this point, well, you could put it into KML, but it will have no effect in Google Earth or Maps. You can't go underneath the Earth or the ocean in Google Earth. Okay. All right, I'm going to show a couple of samples of the Earth API. So did everybody make the keynote this morning and see the Earth API demonstration? Okay, so I'm not going to show Monster Milk Truck again, although that's one of my favorites. But I am going to go to the Earth API. What I want to show, particularly, I think the most interesting one for getting started is this one. This is an example of integration using the Google Maps API and Google Earth. So you see here I have a regular Google Maps, which is just hello world. It's got a point and a line, a polyline on it. Now I click on the Earth API. It activates the plugin, and it'll take a moment to load. My network's a little slow right now, so it's going to take a moment to load. And what I'm going to show you when I'm done, actually I could show you, start this now. We can do a view source on the page, and I can just show you that, in fact, this only takes a single line of code to add in the Earth, control there. So if you're familiar with the Maps API, you'll see this is a very standard map. You have a script tag which identifies a source, which puts in this is standard beginning of every Maps API. You put in your own key. You'll need a Maps API key to use the Earth API. And then the initialize function creates a map and sets the map center. This is all standard map stuff. And then this is the single line of code that you need to add to your Maps API application to add in additional control for the Earth API. And I'm getting an error. This is unbelievable. Okay. All right. Standard demo problems. Here, I'm going to try reloading this page. My Firefox has been a little bit flaky recently, so I'm going to click into to Earth, and hopefully this will work. Okay, I seem to be having a little bit of trouble with it. But trust me, it'll work. Okay, so I'm not going to spend a lot of time on this. For some reason, I'm getting an error, but I'm going to. I want to show you. Let's see if I can get a couple of other ones to. Here we go. Okay, so a couple other fun things that you can do is you can create multiple instances of the, I'm going to close this down, of the Earth plugin and use them at the same time. And they don't all have to be synced up. So you have multiple instances on the same page. I'm going to spend a little time waiting for this to load. And while I'm doing that, I'm going to tell you that currently the Earth API is only available for Windows, but we are working on, and we'll have very soon, Macintosh and Linux versions of the plugin. Currently it works on Mozilla variant browsers, including Firefox, and it works in IE, Internet Explorer. So I seem to be having a little trouble with my machine. This was working earlier. So I'm not going to spend a lot more time on it, but you can do, oh, here we go. Okay. Actually showing up. There we go. Okay, so this is one of the things that I think is most fun. I can go to pretty much anywhere in each of these different ones on the same page, and one of them has got an error. Okay, I know I'll be taking this back to Mountain View to talk to some people about this, but and I can do interesting things like, let's see if this will take me to San Francisco. Okay, I'm getting another little error. But I can turn on buildings and borders and roads and terrain. So it gives you access to 4 of our base layers, which you can use, the 3D the 3D buildings, the borders, and the roads, which I think is an interesting, and it's really useful. You saw that in the Monster Milk Truck demonstration. Those were the buildings that just came with the plugin for free. So, okay. So, all right. So I want to switch back to KML, and let me open up Google Earth again. I want to show you a couple of the other properties of KML. So particularly, I want to talk about network links. Network links, I said this before, but they allow you to point to a static file or to a script that generates a file. And static files are fun because you can work with them, you can hand code them. But if you have a script that generates a file, say out of a database, or if you have, for instance, a CSV file and you want to automatically generate based on that, then that's a pretty useful thing to do. So what I want to show you is that Google Earth allows you to embed some default variables, and there's a couple of approaches to this. One is, the first one I'm going to show you is called view-based refresh. So basically, a network link allows you to set an element in the network link that says that this will, when you stop the browser, the Google Earth browser, it will send to the server a request for a new, it will send a request for the script that you have, that you generated. Now let me turn off the Tokyo. So it'll send to the server a request that says, this is what I'm looking at. This is the bounding box of the of my browser, my Earth browser. So give me something that's relevant to that. So this is useful because it allows you to reduce bandwidth. A lot of times you'll have a database of thousands or even hundreds of thousands of points. This allows you to send a request to the database that says, only give me things that are in this particular screen, in this particular area. And so that reduces bandwidth, it reduces load on the server, it reduces load on the client. It's only things that are going to be relevant and will show up. So I have an example of that. Let me make sure, yeah, that's on. I'm going to go to New York City. I have an example that looks for personal ads. We have a service called Google Base, which is basically a place where you can upload arbitrary XML files that have basically anything that you want in them. So what this script does is it queries Google Base for personal ads. And then does a little transformation on them and pushes it out. Now, Google Base allows you to specify two things. It allows you to either specify a bounding box, which is perfect for Google Earth, or to specify a radius from a certain point. And then what it does is it returns a bunch of results. And in this case, it returns a postal code. And so in the US postal code, and then I use the Google Maps API to geocode that postal code. So these aren't actual addresses, but they are pretty close to where they actually live. They're within the postal codes. So you'll see that there's, each one of these contains information, and I deliberately clicked on one that I had tested out earlier that did not have a picture in it because I didn't want to embarrass anybody. But this is, you can see, information about that person. So I like to entitle this portion of the talk, Dating Using Google Earth. So then you can see if I move here, in 4 seconds you'll see this will start to query the script again. Come on. And while it's doing that, I want to show you what that actually looked like. So okay. All right, my machine is doing something it never does, which is freezing up on me. Okay, here we go. All right, so what I'm gonna do is I'm gonna show you the web server log. Basically how I did this was I pointed my network link at a script, and I'll show you the network link in a second, at a script on my, that's running on a web server that I have on my hard drive. So let me show you what the access log looked like for that. So this is the request that was sent to the web server. You see basepersonals.py, so that's a Google base personals, it's a script. It's a Python script that I wrote. And then it's got parameters here, and it says bbox equals, and then you'll see there are 4 points. There's this negative 74 dot 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 dot, 40 dot 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 dot, negative 73 and 40. And that is the west, south, east, and northern points of the bounding box. So it sent that to a script, which then use that to query Google Base. But if we look at the actual file, and let me show you what the file looks like. This is what it looks like. So you see it's a network link file. It's a name, open one. It's got a link, and the href points it to this particular script, and then it says view refresh mode on stop. You see nowhere here does it specify that there's a bounding box, but Google Earth by default, whenever you set the view refresh mode to on stop, will append a bounding box. The bbox equals west, south, east, and north parameters. So that's one way you can use this by default.